So let's do some of the problems from exercise 5.1. So this is exercise 5.1. Okay. In 5.1, we had a system of linear equation. We had a system of linear inequalities, and we solved the system of linear equation and inequalities. Okay. Let me choose a problem from here. So let's do, okay, 24. 23 is a homework for you. So I will go ahead and do 24, okay? So we have 1/5 of x minus 3 over 2y equals to 4. This is one equation, okay? This is one linear equation. Let's call it equation 1. And the second, we have negative 2 over 3x plus 1 over 2y equals to negative 13 over 3. So this is equation 2. And we are asked to use elimination method to solve this system of equation. Okay, so using elimination method means we have to eliminate one variable. It does not matter you eliminate x or y. Okay, and in order to eliminate, what we need to have? We need to have the, yes.
We need to get rid of the fractions.
Yeah, that would make us easier. So we have the fraction here, and if you get rid of the fraction, so it will be easy for you. But is it necessary?
No.
It's not necessary. Okay, but if you wanna get rid of the fraction, yeah, you can. So what would be the option of getting rid of the fraction here? How do you get rid of fraction? So we have 1/5, we have 3 over 2. What do we do to get rid of this denominator? We use the same denominator to multiply both sides of the equation, right? Now we have the two different denominator here. So you need to multiply 2 times. Okay, but if you want to get rid of denominator, go ahead. Okay, but even without getting rid of denominator, we can solve this one. Now in order to eliminate, we have to have the same coefficient with opposite sign for one variable. Okay, now here our x has the coefficient 1 over 5. Okay, and this has a 2 over 3. The next, y has a coefficient negative 3 over 2, and the second equation has a coefficient of y as a 1 over 2. Now let's try to make the same coefficient for one variable with the opposite sign. Now which one would be the easier here? So it's gonna be easy to eliminate x or y. And what is the reason for that? That's right, they have the same denominator. Okay, it's easy to remove the variable having the coefficient with the same denominator. So here y has a denominator 2, okay, in the equation 1, and in equation 2 the y has a denominator 2. Now the only thing that we need to make same is the numerator. Okay, so numerator of the equation 1 for y is negative 3, and we have positive 1. Now how can we make negative 3 for equation 2? So we want negative 3 here. Okay, so we want positive 3. Instead of positive 1, we want positive 3, so that we get negative 3 over 2 and positive 3 over 2, and we can cancel y. So let's multiply our equation 2 by positive 3. So we multiply every term. Okay, make sure you are multiplying every term of the equation by positive 3. So let's rewrite. So our equation 1 is 1 over 5x negative 3 over 2y equals to 4. So when you multiply, how do we multiply? So 3 times negative 2 over 3 is, so you multiply numerators, right? So 3 times negative 2, that is negative 6 divided by 3x plus 3 times, then you multiply 1 over 2, that is 3 times 1 is 3 over 2y equals to 3 times negative 13, that is negative 39 divided by 3. So now what we have? So the coefficient of y, now let's see, the coefficient of y is negative 3 over 2 and positive 3 over 2. If we add these two equations, it cancels. So every time just try to make the same coefficient with opposite sign for at least one variable, okay, in the elimination method. Now let's add these two equations. So we're gonna add these two equation. Okay, so this y cancel here, we can cancel this. So we have 1 over 5 x plus, so what is negative 6 divided by 3? That is negative 2, right? So we have negative 2x equals, so we have 4 plus, and negative 39 divided by 3 is negative 13. So 1 over 5x plus negative 2x, okay, equals 4 plus negative 13. Do you have any equation up to here? Now on the left side we have the like terms, so we're gonna add. Okay, so 1/5 plus negative 2x. Now how do we do that? So what you can do is that you can factor out x here and add the coefficient. So you have the x common factor, right? So let's factor out x. So we have 1/5 negative 2 and x. Is it same? So you factor out. So when you are adding the like terms, you are adding the coefficient, right? So we have the coefficient 1/5 and negative 2. So we keep the coefficient together and we have our variable x equals, we have 4 plus time negative 13, that is negative 13. So this is 4 minus 13, that is negative 9. Okay. Now on the left side, now what is 1/5 minus 2? We need to have a common denominator, right? 2 has a denominator 1, so let's make it 5 by multiplying in the denominator and numerator by 5. Okay, so we have 1 minus 2 times 5, that is 10, right? So we have 1 over 5 minus 10 over 5, or you can just write directly, x equals negative 9. So 1 minus 10, that is negative 9 over 5, x equals to negative 9. Okay. Now how do we solve this equation? So we need to get rid of denominator, and our denominator is 5. In order to get rid of this denominator 5, we multiply both sides by 5. So this 5 cancel. So we have negative 9x equals to negative 9 times 5, that is negative 45. Now we get rid of negative 9, and for that we divide both sides by negative 9. So our x is positive 5. Okay, x is equals to 5. You make the coefficient, same coefficient with opposite sign. Okay, you add the equation, then you get rid of one variable and you solve the equation. Now once we have x, what is our next step? We substitute x equals to 5 in any one equation to get the value for y, right? So let me take any one equation, it doesn't matter. So let me choose my equation first. So our equation 1 is 1 over 5x negative 3 over 2y equals to 4. Now you substitute x equals to 5 in this first equation, and you can choose any equation. So we have 1 over 5 times 5 for x minus 3 over 2y equals to 4. So 1 over 5 times 5, that is 1, right? So you can cancel this 5 here. So we have 1 minus 3 over 2y equals to 4. Now we need to get rid of positive 1. So we subtract 1 on both sides. So you subtract 1 on both sides. So positive 1, negative 1 cancel. We have negative 3 over 2 y. So we have negative 3 over 2y equals to 4 minus 1, that is 3. Now we need to get rid of this denominator. And how do we do that? You multiply both sides of this equation by the same denominator, which is 2. So you multiply both sides by 2. So these two cancel. So we have negative 3y equals to 3 times 2, 6. Now you divide both sides by negative 3 to get rid of negative 3 from y, and we get y equals to negative 2. So we have x equals to 5, we have y equals to negative 2, and you write x and y together in order pair. So 5, which is x, and y is negative 2. So this is the solution for this system of linear equation. 5, negative 2 is the solution for this system of equation. Okay, so it means when we plot a graph for these two equations, 5, -2 is a common point, okay? These two lines intersect at 5, -2. So if we have the graph for these two lines, they intersect at this point, 5, -2. Okay, so this is the linear equation. Do you have a question on this one? Okay, now let's do one problem from linear inequality, okay? So you have 55, your homework. Okay, let me do a 55. I know this is a homework for you, but let me go ahead and do this for you. So we have a 55 and we have the linear inequality. So we have y less than equals to -2. We have y greater than equals to -5. And we have x less than equals to -1. So we have these three inequality, system of inequality, and we have to solve, we have to graph the solution set for this system, okay? So the very first thing, we take each inequality, okay, one by one. So let's take our first inequality, and first inequality is y less than equals to -2. If you are solving the system of inequality, the very first step is you replace your inequality sign, okay? You replace your inequality sign by equals to sign. So we have y equals to -2. That is the first step. You are replacing your inequality sign by equals to, okay? Now we graph this equation. So we have the equation now. We graph this. Now what kind of graph do we get for this equation? So we have y equals to -2. What kind of line do, is it, we get a straight line, right? Now what kind of line do we get? Y equals to 2. It's a horizontal line, okay? We have, if you have y equals to some number, that is a horizontal line. So we draw a horizontal line at -2. So we have -2 here, okay? And you draw a horizontal line at -2. Now, before you draw a line, is your line dotted line or a solid line? It's gonna be solid line, okay? So one more time, if you have less than equals to, greater than equals to, you're gonna use solid line to graph. If you have less than or strictly greater than, you're gonna use a dotted line, okay? Now our inequality has a equals to sign here, so we have a solid line, horizontal line at -2. So we draw a solid horizontal line at -2. That's the next step. First step, you replace your inequality by equals to. Second step, you plot a graph for that equation, okay? And before drawing a final graph, you have to check whether you're gonna have a solid line or a broken line, okay? Now the next step is we choose a point, and we choose a point which is not on the line. You can choose any point which is not on the line. Okay, what point do you want to choose? You can choose any point, but that point should not be on the line.
-3.
Okay, so -3, we need a point. It means you need an x coordinate and you need a y coordinate.
Yeah, 0, -3.
Okay, you want to choose -3, 0. Okay, so let's find out where is that point is. So this point is, so we have -3, 0 is over here, right? Oh, no, sorry. This is -3, 0. Okay, now we have this point. Now let's check whether this point is a solution for our first inequality or not. So our inequality is y less than equals to -2. And we want to check whether -3, 0 is a solution for this inequality or not. And how do we do that? We substitute x equals to -3 and 0 for y. So we don't have x here, so we need to substitute. Our y is 0. 0 is less than -2. Is it true or false? Is 0 less than -2? It's false, right? 0 is greater. So we have false here. So it means we said, it means the solution is away from that point. So our testing point is this one, okay, -3, 0. So the solution for this inequality is away from the point. So every point below the line, away from the point, is the solution for this first inequality, okay? So whatever point you have below this line, solid line, is the solution. So this is all for the first inequality. Now we repeat the same process for the remaining inequality. Our second inequality is y greater than equals to -5. Okay, so our second inequality is y greater than equals to -5. First step, you replace your inequality by equals to sign. So we have y equals to -5. We plot a graph for this equation. So this is also a horizontal line, right? And where do we draw a horizontal line? So we have this equation. So we have y equals to a number. So we get a horizontal line. And where do we draw that horizontal line? We draw at -5, right? So let's say this is -5. Now, do we have a solid line or a dotted line? Solid, because we have greater than equals to. We have equals to here. So it means we're going to have a solid line, okay, at -5. Now we choose a point. Now let's choose a point. So what point do you want to choose? You can choose the same point or any point, but that point should not be on the line, okay? So give me a point that you want to choose.
0, -4.
0, -4. Let's see where is this point. Okay, so 0, -4 is over here, right? Now let's check whether this is a solution for our inequality or not. Our inequality is y greater than equals to -5, okay? Now we check whether this point, this is our testing point, we check whether this point is a solution for this inequality or not. So our y is -4. -4 is greater than -5. Is it true or false?
True.
It's true, right? It means we're gonna set, okay, now so where is our testing point? Is above the line. So every point above this line is the solution set for this second inequality. If it's true, you are setting towards the point. Okay, if it's false, you are pointing away from the point. Now we have one more inequality. Our third inequality is x less than equals to -1. Okay, first step, you replace your inequality by equals to. So we have x equals to -1. And what kind of line do we get? Vertical line. And where do we draw a vertical line? Yes, right. So we draw a vertical line at -1. So let's say this is -1. So now is it a solid line or a dotted line? Yes, because we have a equals to here. So we're going to draw a solid line at -1. So vertical solid line at -1. Okay, now we choose a point, testing point. So you choose any point. Okay, what point do you want to choose?
-2, 0.
-2, 0. Okay. Now we check whether this point is a solution or not. Let's find out where is -2, 0. So -2, 0 is over, okay, so over here, right? Okay. Now let's check this point is a solution or not. So our inequality is x less than equals to -1. Now you substitute x equals to -2. So we have -2 less than -1. Is it true or false? It's true, right? So we have this line and our testing point is this one. So you are pointing towards this point. So every point on the left of this line is the solution here. Okay. Now, if you said it, it's going to be easy. Okay. So this is the solution for the second inequality. Okay. So every point here. Let me choose a different color. Okay, now here, so this is for the first inequality, and for the third one, so this is the one. Now what we are looking here, we are looking the common portion, we are looking for the common part, which is the solution for all the three inequality. So which part is the common solution here? Okay, now here, just let me make it clear. So we have this line here pointing upward, right? So we have this red line here. So we have this inequality is pointing downwards, okay? And we have this equation pointing on the other side. So this portion, so here, okay, so here this portion, is the common portion for all these three inequality, right? So whatever points we have here is the solution for this system of inequality. Okay, we have like infinite solution. So we only use the graphical method. So this is the graphical method of solving the linear inequality. Get? Okay, do you have any question on this one? Now we will have a similar method in our section 5.2. Okay, 5.2 is we have the three variables. We have to solve the equation and we have to solve the linear inequality as well. So let's go to our section 5.2. Okay, so in 5.2 we have the system of linear equation in three variables. The only difference is that we have three variables. In our previous we had a two variables x and y. Now we introduce a three variable x, y, z. So you have a linear equation and the linear equation has a three variable. Okay. Now when you have a two variable, what kind of graph do we get? So if you have a x plus y equals to 2, what is the graph of this linear equation? So if you have x plus y equals to 1, what kind of graph do we get? So we have x plus y equals to 1. So this is a linear equation with a two variable. Now if you graph this equation, what kind of graph do we get? We get a straight line. Okay, so we get a straight line. Okay. Now if you have three variable, what does it mean? So if you have x plus y plus z equals to 5. So we have the three variable. It does have a real meaning. Okay. So here, so we have our Cartesian coordinate system. We had a x-axis, we have a y-axis, and this is the origin. So when we talk about Cartesian coordinate system, so here we have the two dimension. Our x-axis is the one dimension, y-axis is the second dimension. Okay. Now when we have a three variable x, y, z, we introduce a new dimension. Okay, the third dimension. So let's say this is our x-axis. Okay, this is our y-axis, and we have a new axis here, z-axis, and the angle between these axes is always 90 degree. Okay, we introduce a new axis. This is a three dimension. Okay, so if you have a x and y, that is a two dimensional. If you have a x, y, z, there is just a third dimension. Can you just give me an example of any object with a two dimension? There's like a real object with a two dimension. So you must have like a two side when you think of any object with a two side. That's right, plain paper, right? So plain paper has only the two side, right? So you have the length and you have the width. So that's the two dimension picture. Now what about the three dimension? Ball, right? So ball has you have a height. There's a one more. That's the height. Okay. So ball has a three dimension. Okay, so when we talk about a ball is a sphere, and when we talk about the equation of a ball, we have the three variable, x variable, y variable, z variable. Okay, our circle has a two variable, right? So our equation of a circle is x minus h square plus y minus k square equals to r square. This is our circle. We have x variable, we have y variable. It means we can draw our circle on the two dimension. Okay, but if you want to draw a sphere, you need a three dimension. Okay, there is a one more dimension, that is a z dimension. Okay, now what about us? Are we a two dimensional or a three dimensional? What do you think of like ourselves? It's a three dimension. Okay, so we have a height, we have a length, we have a width. Okay, so now similar like here, what we can consider is that, okay, now if you just take, okay, now let's take this corner here. Okay, now we have a three dimension here. So if we take this corner as the origin, okay, we can take this as our x-axis. Okay, and this is our y-axis, the other corner. The angle is 90 degree, right? And the vertical, this is our z-axis. And if you see, in between each axis, they are the 90 degree. Okay, so here we are talking about the three dimension in this section. Okay, that's the difference here. Okay, now here, so we have the linear equation and we have the 3 variable, it means we are talking about the 3-dimensional object. Okay. Now we try to solve this system. So solving means we try to find a common point. Okay, we try to find a point where these 3 linear equations intersect. Okay, now what happens if you have 3 dimension intersecting at a point? So if you have the 3 dimension, okay, now let's take, so this is, okay, let's consider this is our horizontal, is our x axis, this is our x axis, and this is our z axis. Okay, so if you only take 2 dimension like x axis and z axis, what do we get here? What is this portion here? So you have this x axis and that is your y axis. Now what is this? This is a one plane, right? We get a plane. Similarly, let's take that is our y axis and that is our z axis. We get another plane. And when those 2 planes intersect, what we have there? A line. That's right. So when we have a 2 plane intersecting, we get a line. Okay. Now here I think I do have here. Okay. So we have here different cases here before we solve. So if you have the inequality, okay, if you have the equation and they are intersecting at a point, then we get a one solution. Okay, we might get a infinitely many solutions. Okay, we might get infinitely many solutions if all the planes overlap each other. Okay, there might be a no solution. So what would be the case of no solution? If they are parallel to each other. Okay, and also there might be a no solution here. You have the 2 plane parallel to each other. Okay, so you have this first plane and second plane parallel to each other, and the third plane intersecting 2 plane. So here, yes, so we are looking for a point. Okay, we are looking for a line where all the 3 plane intersect each other. Okay. Okay, now here let's go and see this equation. So we have this system of linear equation. We have 3 variables here and we need to solve. So we need to find what is x, what is y, what is z, which is true for all these 3 equations. Now here, if we see our equation, so our equation 1 is x plus y minus z equals to 10. This is, let's call this is 1. So in 2 we have y plus z equals to 2, and in third our equation is 3. So from here we already know one thing. So what do we know? We already know what is g, right? G is 2. So if g is 2, is there any way we could substitute g and find the value for other variable? Right, so in second equation we have y plus z equals to 0. Now you substitute g equals to 2 in the second equation and you can find y. So here let's substitute. So let's substitute g equals to 2 in our equation 2. Okay, so that is we have y plus g equals to 0. Our g is 2, so we substitute, so we have y plus g is 2 equals to 0. Now this is equation. We know how to solve this. So you subtract 2 on both sides and we get our y as a negative 2. So we know what is g, which is positive 2. We know what is y equals to negative 2. Now we need value for x. Now how do we find x? We know g, we know y. How do we find x? In which equation? Number 1. So you substitute g equals to 2 and y equals to negative 2 in equation 1. So we substitute y equals to negative 2 and g equals to positive 2 in equation 1. Our equation 1 is x plus y minus g equals to, it is 10. Okay, now let's substitute. So we have x as it is, we don't know what is that. Our y is negative 2 and g is positive 2 equals to 10. We solve this one. So we have x minus 4 equals to 10. You need to get rid of negative 4. So you add 4 on both sides. And our x is 10 plus 4, 14. So we have x, we have z, and we have y. Now you write all these in a pair form. Okay, so now you write down all this together. So you write down your x coordinate, which is 14, your y coordinate, which is -2, and your z coordinate, which is 2. So this is a point in the 3 dimension where all of these 3 plane meet together. Okay, so this is a common point. So this is the solution for each of the plane, 14, -2, and 2. So this is a 3 dimension, x, y, z. First is your x coordinate, okay, second is y coordinate, and the third is z coordinate. Okay, now let's see what if we have any more example. Okay, yes, we do have example 2. Do you have any question on this one? This is the easy one, okay, because we already know what is z. You substitute z in equation 2, you get y, and you substitute in equation 1, you get x. Okay, but every equation, every system is not easy like this one. If we go to the next example here, do you have any question here? Okay, if so, let's go to our second example here. So we have -2x plus 2y plus z equals to -6. So this is our first plane. Okay, let's call it equation 1. So we have x minus 2y plus 2z equals to -1. So this is our 2. And we have third plane. Now we need to find the solution for this system of equation. Okay. Now, so here, so when you have this system of equation with a 3 variable, we have to use the elimination, and we also have to use the substitution. Okay. So sometime we might need to use substitution, or we might need to use elimination. So let's use elimination method. Okay, now let's take 2 equation and eliminate any one variable. Okay, so you can choose any 2 equation. So you can choose 1, 2, 2 and 3, or 1 and 3. You can choose any 2 equation, and we try to eliminate any one variable. It does not matter what variable do you eliminate. Now, do you have any preference to choose equation?
Okay, so you can multiply the second one by 2.
Uh-huh.
So you can eliminate the y.
So you, okay, now do we need to eliminate, so do we need to multiply? So how do we know whether we can eliminate or not? So if you have the coefficient, same coefficient with the opposite sign, then we can eliminate, right, without multiplying. Now let's check the coefficient of y here, because so here the first equation has a coefficient +2. Second equation has a coefficient -2. Now if we add equation 1 and 2, we can eliminate y easily, right? But you can, if you want, you can eliminate g. And in order to eliminate g, you might need to add equation 1 and 3, because so we have +g here and we have -g here. So if you add equation 1 and 3, you can eliminate g. It doesn't matter, you can eliminate any one variable. So at the very first, you choose any 2 equation and eliminate any one variable. It doesn't matter what variable. Okay, now what variable do you want to eliminate, y or g? Okay, if you want to eliminate y, you have still 2 options. You can add 1 and 2, or you can add 2 and 3. Still same thing. Okay, we eliminate y in both cases. So our first equation is -2x plus 2y plus z equals to -6. Now let's add this equation with equation 2. So we have x -2y plus 2z equals to -1. So we are adding here. Now if you add here +2y, -2y, so y is eliminated. So we have -2x plus x, that is -x plus z plus 2z, that is 3z equals to -7. And let's call this is our equation 4. So we have -x plus 3z equals to -7. And on the very first step, you can choose any 2 equation and you can eliminate any one variable. Okay, it's not always y. You can eliminate x if you want. You can eliminate g if you want. Okay, now in the second, we have to be careful. Now we eliminated y. Now we have to choose other 2 equation and eliminate the same variable y. Okay, we choose 1 and 2. Okay, we already choose 1 and 2. Now what option do we have? So we already had 1 and 2. Now we're gonna choose 1 and 3 or 2 and 3 and eliminate the same variable that we eliminated. We eliminated y. So you're gonna choose equation 1 and 3 or 2 and 3 to eliminate same variable y. Now what equation do you wanna choose? Do you wanna choose 1, 3 or 2, 3? And we are eliminating y, okay? You can't eliminate g here, you can't eliminate x here. At the beginning, you can eliminate any one variable, okay? And next time you are eliminating, you have to eliminate the same variable, okay? Since we eliminated y, okay, by adding 1 and 2, now let's choose our equation 2 and 3 to eliminate y. We have to eliminate y. So let's choose equation 2 and equation 3 to eliminate y. We have to eliminate the same variable. So our equation 2 is minus 2y. So x minus 2y plus 2z equals to negative 1. Equation 3 is 3x plus 2y minus g equals to 3. So we add these two equations. Negative 2y, positive 2y, it cancel. X plus 3x, 4x. 2z minus g, that is plus g equals to negative 1 plus 3, that is positive 2. And let's call this is our equation 5. So from 3 different equations, you have to make a pair. You get the 3 different pair, okay? And by adding those 3 different pair, you have to eliminate the same variable. Okay, now we have equation 4 and 5. Now what kind of equation are 4 and 5? So equation 4 and 5, these are the system with a 2 variable, right? And that's what we did in section 5.1. So we use the 5.1 elimination method to solve this equation 4 and 5. Now let's solve equation 4 and 5. So let me write 4 and 5 one more time. So our equation 4 is negative x plus 3z equals to negative 7. That is equation 4. And our equation 5 is 4x plus z equals to 2. So this is 4, this is 5. Okay. Now let's eliminate. Now what variable do you want to eliminate here from 4 and 5?
X.
You want to eliminate x, okay. Now to eliminate, we must have a same coefficient with the opposite sign. So x has a coefficient negative 1, we have a positive 4. Now how do we make the same coefficient? Multiply equation 4 by 4, positive 4. So let's multiply our equation 4 by positive 4. And after this, after multiplying, we get 4 times negative x, that is negative 4x. 4 times positive 3z, that is positive 12z, equals 4 times negative 7, that is negative 28. Our equation 5 is 4x plus z equals to 2. We add these two equations. Negative 4x, positive 4x is 0. 12z plus z, that is 13z, equals negative 28 plus 2, that is negative 26. You divide both sides by 13. So we get g equals to negative 2. This is what we know. Now we know what is g. So g is equals to negative 2. We still need to find what is x. We still need to find what is y. Now is there any way to find x and y with the help of g equals to negative 2?
For x, we just plug it back in the equation 4 or 5.
Yeah, so if you substitute g equals to negative 2 in the equation 4 or 5, we know what is x. So let's substitute g equals to negative 2, okay? Now let's substitute g equals to negative 2 in equation 4 or 5. It doesn't matter. So we substitute g equals to negative 2 in equation, let me take 5. You can choose any, 4 or 5. So we have 4x plus our g is negative 2. So let me write down the equation equals to 2. So we have 4x, g is negative 2 equals to 2. You add 2 on both sides. So you add 2 on both sides. So this cancel. So we have 4x equals to 2 plus 2, that is 4. You divide both sides by 4. And we get x equals to 1. So our x is 1. So we have x, we have z. Now we need to find y. And how do we find that?
Go back to the pick 1 through 3 equation.
That's right. So we go back to our system here and you substitute y, you substitute x, you substitute g, and you find your y. And you can choose any, okay? So here, Now you substitute x equals to 1, g equals to -2 in any one equation 1, 2, 3. So let me choose equation 1, or you can choose 2 or 3, doesn't matter. So equation 1 is -2x plus 2y, -2x plus 2y plus g equals to -6. So we have -6. Now let's substitute. So we have -2 for x, which is 1, plus we have 2, y as it is, our g is -2 equals to -6. Okay, we have the like terms here. So -2 times 1, that is -2 plus 2y, -2 equals to -6. We have the like terms here. Our like terms is -2 and -2. So -2, -2, that is -4. So we have -4 plus 2y equals to -6. You add 4 on a both sides to get rid of -4. So we have this cancel. 2y equals to -6 plus 4, that is -2. At the end you divide both sides by 2 and we get y equals to -1. Now you write down x, y together, x, y, z together. So you write down x at first, 1. You write down y, which is -1, and you write down g, which is -2. And this is the solution for this system of equation 1, -1, -2. So this is a point in the 3 dimension where these 3 planes meet each other. Okay, I know it's a lot here, but if so, it's not difficult. Okay, you have to just work a little bit more, but it should not be a difficult for you. Okay, 5.1 and 5.2 is pretty similar. Okay, I didn't make an announcement, but you will have your exam 2 on the Tuesday. Okay. So from section 2.1, 2.2, 5.1 and 5.2. So it's going to be only 4 sections, and we'll have our second exam on Tuesday.
What are the formulas going to be included for the term?